mole solute per kilogram of water. So, tonicity is relative concentrations of specific solutes. This is your total solute concentration. You can say you have, like 0.1 molar sodium and 0.1 molar chloride and 0.1 molar potassium all in the solution, but your total osmolarity for all solutes is going to be this plus this plus this. So that's what this means. Your total solute concentrations. If you have a 200 milliosmolar solution, that means you have added 200 millimoles of all the different solutes you put in there put together. So if you've got potassium, chloride, bicarbonate, anything that doesn't dissociate, any type of ion, whether it's just, copper ion or, phosphate ion, any type of ion that has a molar concentration, all those added up together are included in your osmolarity and osmolality. Tonicity refers to, you can be isotonic for a specific ion. In other words, you can be isoosmotic. Two solutions can have 200 moles is too high. So 200 millimoles of solution, of solute per liter of solution, right? They can both have 200, but one can have 100 millimoles of sodium and the other can have 150 millimoles of sodium, and they're not the same tonicity for sodium, right? They're going to behave differently because one has more sodium in it than the other. They have the same total concentration of solutes, 200 over here and 200 over there. But one can have more of any one than the other, and that's going to also affect how it behaves. So, down here, I've given an example over here of sodium. So 1 molar of sodium chloride, when you put it in an aqueous solution, it dissociates into 1 mole of sodium ions and 1 mole of chloride ions. Okay? So this difference affects osmolarity and osmolality, right? When you split that, you now have a mole of sodium plus a mole of chloride, which means you have a 2 molar solution for all solutes. But it doesn't affect tonicity, meaning that you have 1 mole of this, right, and 1 mole of that. Like it goes 1 to 1. Does that make sense? Because there's 1 mole of sodium here and there's 1 mole of sodium ions here. Okay? So over here, so this wouldn't do this much longer, but it's an easy example. So this is H2CO3. Okay, so this is this has multiple states, right? H2CO3 can go to HCO3 minus plus H2 plus, which is bicarbonate ion and hydrogen ion, but it can also go all the way down to 2 hydrogen ions and the carbonate ion, and then this can further go to water and carbon dioxide. I'm ignoring this middle step right now just to make a point. Okay, so if it fully dissociates without going to its gaseous form, if you stay aqueous, when you fully dissociate this in water, you get 2 hydrogen ions and 1 carbonate ion, right? So this affects its osmolarity and osmolality, right? Because, so you have 1 mole of this, now you have 2 moles of this and 1 mole of this, which is 3 total moles. Because you have 2 times a mole of hydrogen plus a mole of carbonate, and then that's 3 moles total in solution, right? Does it affect tonicity? So that depends. Tonicity is always a relative term, so it will depend on what you're comparing it to. In other words, if you just made this solution, you now have 2 hydrogen ions and 1 carbonate ion. Over here, you have 1 hydrogen ion and 1 carbonate ion. This one is now hypertonic relative to this one. So I'm going to do tonicity in a graphic representation on the board. And just once I take a picture of this stuff and erase it. But are we good on osmolarity? The idea that it's total number of solutes in solution. That it can be all of one kind or it can be 40 different kinds, and in our blood it's really, 40,000 different kinds. I mean, there are main players and minor players, but there are a lot of different solutes involved in the total amount of solution. That's osmolarity. Tonicity is a relative concept and has to do with comparing a specific substance to another, like a specific ion or a specific compound. Okay, so I'm going to take pictures of this, I'm going to erase it, and then I'm going to do pictures.